Hello guys, so if you are writing 2026 Jamb and your exam is starting from April 16, then this video is for you. Now in this video, I'll be doing three things for you guys. The very first thing is that I'll be teaching you guys how to solve exam-based question from Jamb physics syllabus, okay? Yeah, the second thing is that I will show you guys how to solve them easily with the easy trick. Then the last thing is that I will also be showing you guys where and where not to expect question from in your Jamb physics, okay? Now before I start with this question, and there's something I want to tell you guys. Generally, Jamb physics is divided into three parts. The very first part is mechanism, second part is wave, and the third part is electricity. So you have to expect question from this part. Now let's continue now. These are the numbers of topics under mechanism. Topics like measurement and units, scalar and vector, motion, gravitation, equilibrium of forces, work energy and power, friction, machine, pressure, elasticity, temperature, and etc. Okay, yes. Now topics on that way we have sound wave. Topics like sound wave, light wave, refraction, reflection, and so on. Then topics under electricity, we have topics like electrostatics, capacitor, resistor, current electricity, semiconductor, and so on. Okay, so in this video, I'll be solving exam-based question from Jamb physics syllabus. The other thing I'll be doing for you guys is that I'll be showing you guys easy way to solve them. Then the last thing is that I'll also be telling you guys where to the topics you need to expect question from. Okay, yes. Now let's start with the very first part of this video. Okay, so under mechanism, the very first part is measurement and units, right? Yes, so let's start with the very first part, which is measurement and unit. Now they will definitely ask you questions. Yeah, they will definitely ask you questions from dimension, okay, under measurement and unit. So I'll be showing you guys easy way to solve questions under dimension. Okay, yes. So let me clean this part first. Now I'll be showing you guys how to solve questions under dimension easy way. Okay, yes. Now before solving questions under dimension, these are things you need to know. Okay, so I'm coming. Let's say these are quantities. These are quantities. Then they are dimension. Okay, yes. Now for quantity like mass, the dimension for mass is what? Quantity like mass, the dimension for mass is capital letter M. Quantities like length, dimension for length is capital letter L. Quantities like time, dimension for time is what? Capital letter T, right? Yes. Then quantities like area, dimension is what? Is L square. Then quantities like acceleration, velocity. Okay, I think this. Then let me still use. Okay, yeah, acceleration lt raised by -2. Then quantities like velocity is lt raised by -1. Okay, so I think these are the basic things you need to know. Okay, yes, these are the basic things you need to know. Now when you want to solve any questions under dimension, these are the things you need to know. The very first thing to know is that you need to know the formula of the quantity they're asking you to look for a dimension for. Don't you understand? So the first thing is what? You know the formula. Okay, yes. Yeah, so that's the very first thing. Okay, you need to know the formula. The second thing you need to know is to know how to solve using indices. Okay, yes, how to solve using what? Indices. So these are the two things you need to know when solving questions under dimension. At first, know the formula of the quantity you are asked to look for a dimension for. The second thing is know how to use indices to solve, right? Yes. Now I'll be showing in this video, I will show you guys everything. Okay, now let's start with the very first question. I said, which of the following is dimension of pressure? Where is dimension of pressure? Now the very first thing I told you guys to do is to do what? To know the formula of the quantity, right? Yes. And in Jamb, they'll majorly ask you question from gravitational constant, pressure, then at times viscosity. Okay, so the very first thing you need to do is what? Know the formula of pressure, right? Pressure is what? Formula for pressure is what? Force over what? Area, right? Yes. Then the next, what are we going to do next? We break down this. We break down these quantities. Okay. Remember, what is formula for force? Formula for force is what? Ma, right? So in place of 4F, I put what? Ma divided by what? Area, right? Yes. Then what next? We move towards this. right? Now, what is the dimension for mass? Please, you can take note of all this. That is for those who don't know how to solve using dimension. For those who don't know how to solve dimension, right? So let's continue now. What is dimension for mass? Dimension for mass is what? Is capital letter M, right? Yes, what about dimension for acceleration is what? L t raised by what minus 2, right? What about dimension for area? Is L t raised by what 2. Now we done yet? No. The next thing is to simplify this further. Okay. Now what I'm going to do? What I'm going to do next? We need to have the knowledge of indices. Okay. So I'll be giving now. There are different laws of indices, right? So I'll just tell you that there are just three laws we need to know. Right. There are three laws we need to know to solve all this type of thing. Okay. Yes. The very first law under indices is okay. Let me just give you one of the very first law. Okay. Now, the very first law is that when two base, okay, when the same base, right? When the same base carrying, these are the same base, right? When the same base carrying, I think different power or the same power, okay? When the same base, this is the first law, right? Yes. So the first law states that when the same base carrying powers, when the same base, when they are carrying power and they multiply each other, when the same base are multiplying each other, what are we going to do? We take what? We take one of the base, right? That's when they are multiplying each other. When the same base are multiplying each other, we take one of the base and we do what? We add their power. Okay, something like this. Let's say, for example, L1 times L1. Now these two are the same base, right? What are we going to do? What? We take one of the base, we do what? We add their power. 1 plus 1 should be what? L power 2, right? Yeah, so this is one of the first, this is the first law, right? So this is one of the law. Then another law is the opposite of this. Now the other law on in this state that when the same base, okay, so it said that when the same base, right? When the same base, these are the same base, right? Yes, when they're the same base, when they are dividing each other now. The very first one was when they are multiplying each other. We take one with the base, we do what? We add their power, right? Yes. Now the second law is that when the same base, when they are these two guys, they are the same base, right? A, right? Yes. Now when they are dividing each other, it's the opposite of this. We take one of the base, we subtract their power, right? Yes. Look at this one. These two bases are the same, right? When they are multiplying each other, we take one of the base, we add their power. Why this one? We take one of the base, we do what? When they are dividing each other, we take one of the base, we do what? We subtract the power, right? Yes. Then the last one is, okay, I'm coming, let me not clean this part. Okay, so that is all right. So the last part is that when a value is, or when a letter, when a letter is raised to power minus 1, right? Now the last one is that when a value or when a symbol, a letter is raised to power a negative, is raised to the power of a negative number, right? It's still sending as what? It's still sending as what? 1 over the letter raised power what? Raised power the negative value. I don't even understand. Okay, yes, you don't need to add the minus again. I don't even understand. Something like this. Let's say, for example, 2 raised power minus 1 will be what? Will be the same thing as what? 1 divide 2, then raised power what? 1. Okay, yes. So this is the third. So this is the other rule. Okay, yes, that is that is when the value is raised to the power of a negative number. What are you going to do? It means that this one is still something as what? When a value is raised to the power of a negative number, it means that 1 divide that number raised power what? The value. Okay, finish. So that is just, let's say, for example, 3 raised power minus 2. 3 raised power minus 2 is something as what? 1 over 3, then what? The 2. That is just it. Okay, so this is very, very important. These are the three things you need. These are the three laws you need to know. This one, when two bases are multiplying each other, when the same bases are multiplying each other, you take one of the bases, you add their power. The other one is that when the same base, when they are dividing each other, you take one of the bases, you do what? Subtract their power. Then the last one is that when a value is raised to the power, a negative value, it's still sending as what? 1 over that number raised power the value, right? Yes. So that is just it. Okay. So for example, 6 raised power minus 1 or 6 raised power minus 6, for example, 6 sending as what? 1 divided 6, then raised power what? 6. You don't need to add. You don't need to add the negative again. Okay. So that is just it. Okay. Now let's go back to this place. Okay. So let's go back to this place. Now if you look at this place. Okay, so let's even simplify this further. Let's look at, remember in mass, when a value is standing alone, or when something is standing alone, That same thing is still the same thing as what? Still the same thing as that same thing it means that that same thing is used for what? 1, right? Yeah, so when a value is standing on its own, right? When A is standing on its own, you see something as what? A raised by what? 1, right? Yes. So whenever you if you let's go back to this place. If you look at this, M is standing on its own, right? So I can you see something as what? M raised by 1, right? Yes. So when a value or when a letter is standing on it alone, you see that is something as well. That letter is for what? 1, right? Yes. So let's continue. Same goes for L, that right? L is not alone. So it still something as what? L is for what? 1, right? Yes. Now let's simplify this further using the laws of indices. Okay, so let's continue. M is per 1, right? Now if you look at this place, if you look at this place, if you look at this place and this place, find out that is L1 dividing what? L2, right? You look at this place, which of the law does this, like which of the law does it looks like? Looks like this law, right? Yes, you look at it, these two bases, they are these two bases, they are the same, right? Yes, and what are they doing? They are all dividing each other, right? Yes. So what are we going to do? We'll take one of the base, right? Yes, we'll take one of the base, right? We'll take one of the base. What are we going to do? Subtract what? Subtract their power, right? 1 minus this other one is what? 2, right? Right? Yes. So yeah, let's not forget about our T raised by minus 2, right? So that is just it. So 1 minus 2 is what? Is minus 1, right? So this is the dimension for what? Pressure. M1 L raised by minus 1, T raised by minus 2. So M1, okay, M1 L raised by minus 1, T raised by minus 2. So that is just it, okay? Now let me break this down again. We have something like, normally we have something like this. M1, right? L1 T raised by minus 2 divided by what? L2, right? Yes. If you look at these two guys, look at these guys here, find out that both of them, they are what? The same base, right? Yes, so what are we going to do? We just take one of them, right? According to this, we take one of them, right? We'll now subtract their power. So 1 minus 2 will give us minus 1. So that is just it, okay? Yes, so that is just it. Now let's go to the next question, okay? So that is to tell you that you usually see questions from dimension, like question usually come out from dimension, okay? So that is very important. Now let's go to the next one. Question 2. The dimension of viscosity is. Now what did I tell you? Now the very first thing to do when looking for dimension of a particular quantity, know the formula of that quantity, right? Yeah, so what is the formula of viscosity? Formula of viscosity is force times length divided by what? Area times velocity, right? So this is the formula for what? So this formula for viscosity, right? Now let's continue. Now what is the dimension? Remember, force is what? Force is equals to what? MA, right? So whenever I see here, if I put what? MA, right? Then length divided by what? Area times velocity, right? Now let's continue. Okay? So what is dimension for length, for mass? Dimension for mass is what? Capital letter M. Dimension for acceleration is what? Is L raised by minus 2. Then dimension for length is still what? Is L, right? Is L, so so times L, right? Yes. Okay. Yes. So we can just say L, right? Yes. Then divide by what? What is dimension for area? Dimension for area is what? Dimension for area is L2, right? Then dimension for velocity is what? Is L raised by minus 1, right? Yes. Now, are we done yet? No, let's simplify this further, okay? So let's simplify this. Now, if you look at let's simplify this using those laws of indices, right? Yes. So if you simplify it further, n will be equals to what? M. Then look at this guy. Remember, three guys that when a letter or when a letter is standing alone, it's that same thing still means that letter that is still same as well. That letter is power 1, right? Or when when a value is standing alone, let's say 5 is standing alone, still same as what? 5 is power 1. When A is standing alone, still same as what? 8 is power 1, right? So let's go to this place. This L is standing alone, right? L is standing alone, so it's same as what? L is power 1. Look at here, L is standing alone, yeah. So it's same as what? L is power 1, right? Yes. Now let's continue. Now if you look at these guys, according to that first law, when the same base are multiplying each other, what are we going to do? We take one of the base, we do what? We add their power, right? Yes. Look at these guys. This is L1, this is L1. Now these two guys, they have the same base, right? L. So they are multiplying each other here, right? So what I'm going to do? We'll take one of the base, right? Then we'll do what? We add their power. What are the power? 1 plus 1, right? So 1 plus 1 will be what? We give us 2. Then don't forget about this T raised by 1 minus 2, right? Then divide by, now we have L2 here, right? Then times L. Now, if you look at this place here, L is still standing alone, right? So it's same as what? L is power 1, right? So times L is power 1, then T is power minus 1, right? Yes. So what are we going to do next? See same thing. Okay, so since these two bases are the same, what I'm going to do? And look, remember, they are multiplying each other. Look at it, these two bases, they are multiplying each other. What I'm going to do? Take one of the base, right? We'll do what we add their power. So 2 plus 1 give us 3. So everything here will be what? Everything here will be L raised power 3, right? Yes. So are we done yet? No. Now let's continue. Let's simplify it further. Look at these two guys. These two guys, they are doing what? They are what, dividing each other, right? And they are the same base. So what we're going to do, we take one of the base, which is L, we subtract their power 2 minus 3, right? Yes. Take one of the base, they are the same base, right? So take one of the base, we subtract their power, right? So let's do it. 2 minus 3 is what? Is minus 1, right? So it will not be what? Minus 1. So everything here will not be what? Everything here will not be what? Minus 1, right? Yes. Now are we done yet? No. Look at these two guys. This is still the other, this is the other law of indices, right? These two guys, they are the same, like they are the same base, right? So that we're going to do when the same base are dividing each other, we take one of the base, we do what? We subtract their power. So minus 2, then minus, right? Subtract their power, minus 1, right? Minus 1 minus times minus 1 is what? Is plus 1, right? Is plus 1. Then minus okay, I'm coming. So I think, yeah, minus, let me do it, I'm coming. So minus 2 plus 1 is what? Is minus 1, right? Yes. So everything here will be what? T raised power minus 1. So everything here will be what? Will be T raised power what? Minus 1. So this is the dimension for viscosity. When M is standing alone, it's still same as what? M raised power 1, right? So it's M1 L raised power minus 1, T raised power minus 1. So the answer here is B. Okay, so this is dimension for viscosity. Now what about the last part? What about the last part for gravitational constant? What is the dimension for gravitational constant? It's very easy. What I'm going to do next, the very first thing we are going to do is to know what? To know the formula of the quantity, right? Yes. Now what is gravitational constant? Remember, according to Newton's law of universal gravitation, we said that the force between the force of attraction between two mass is very proportional to the product of, yeah, between two objects, very proportional to what? Product of their masses, right? And inversely proportional to what? To the square of their distance apart, right? Yes. So this G here is known as what? Gravitation. This G is known as gravitational constant. So that is what they are telling us to look for. So what are we going to do? We are going to make this guy's subject formula, right? Yes. So I'm going to do make this guy's subject formula. It's very easy. Cross multiply G times M1 times. Remember these two masses. M times M is what? Is M square, right? Yes. So we cross multiply to be what? G M square equals to what? If we cross multiply first times square of the radius, right? Yes. Remember we're looking for G. We have both sides by what? Divide both sides by M square, right? So if you divide both sides by M square, G will be what? G will be equals to what? First times the square of radius divided by what? The square of the mass, right? Yes. Now this, what are we looking for? We're looking for G, right? Yes. So this is gravitational constant. So the very first thing we are going to do, we need to know the formula of the quantity, right? Yes. Since we know the formula, let's continue now. So G is equals to, what is formula for force? Remember, force is what? MA, right? So it's MA, then radius square divided by what? M square, right? Yes. Now what is the dimension for mass? Dimension for mass is capital letter M. Dimension for acceleration is what? Is L to the power minus 2. Then times, now what is radius? Now radius, what is the dimension for radius? Now take note that radius, take note, this is very important. Radius, distance. Okay, let me just use my math. Okay, so just take note that quantities like radius, distance, displacement, height, altitude, breadth, length, they all have the same dimension as length. Okay, see, what is dimension for length? Dimension for length is L, right? Capital letter L, right? Yes. So quantities like radius, distance, displacement, height, altitude, they have the same dimension as length, which is what? Capital letter L. So what is the dimension for radius now? Dimension for radius is what? Is L, right? Remember there are two, is square, right? So put square here, right? Yes. So take note that quantities like radius, distance, displacement, height, altitude, breadth, Name them. Those quantities they have the same dimension as or as length, which is what? Capital letter L. So what is dimension for radius? Dimension for radius is what? L, right? Capital letter L, right? So put the square there. That. What is dimension for mass? Dimension for mass is what? Capital letter M, right? Remember that the mass is squared, right? Yes. Now let's continue. When a value, when a letter is found in alone, see something as what? That letter is per one, right? Right? Yes. Now let's continue. Now if you look at this place, look at this place here. These two guys here, these are the same base, right? What are they doing? They are what? Yeah, well, they are dividing each other, right? When you say base, when you are dividing each other, what are we going to do? We take one of the base, we subtract what? Their power, right? So let's do it now. M1 dividing M2. See something as what? So what are we going to do? This is M1 dividing what? M2, right? We'll take one of the base, right? Which is then we subtract their power 1 minus 2. 1 minus 2 give us what? 1 minus 2 give us minus 1, right? So everything here will be what? Everything here will be what? M raised power what? Minus 1. M raised power minus 1, right? Yes. Now let's continue. Now if you look at this place, this is L1 multiplying L2, right? Look at it. L1 t squared times L1 square, right? Now this is L1 multiplying L2. So what are we going to do? According to the law of indices, when the same base, when they are multiplying each other, we do what? We take one of the base, we add what? We add their power, right? So L1 times L2. So we take one of the base, right? So take one of the base, I'm coming. We take one of the base, we take one of the base, then we add their power, right? Don't forget about the t raised power minus 2, right? Take one of the base, we add their power. So L1 plus 2 is what? Is 3, right? Yes. Then times t raised power minus 2, you have what? T raised power minus 2 here. So this is the dimension for gravitational constant. M raised power minus 1, L raised power 3, T raised power minus 2, right? Yes. So this is how to solve questions on that comes from what? Dimension. And just take note that they will surely ask you guys question from what? Dimension. Just know this basic thing, okay? Yes, just for you to break it down, simplicity by little, then use indices, okay? Yes, that's for those that don't know how to solve dimension. Now let's move to the next part of this revision, of this Jamb revision, which is what? Vectors. Okay, so let's continue. So now let's continue with this next part of questions. And these questions, they are under from where? They are from vectors and scalar quantities. Okay, yes. Now they say which of the following quantities are scalar? Just take note that they will ask you question. They will ask you which of this is a scalar, which of this is a vector. Okay, so please take note of all these type of questions. Okay, yes, that does not mean that they will ask you this exact question. Okay, yes. So which of the following quantities are scalar? Okay. I, electric potential, I, torque, I, momentum, IV, kinetic energy. So which of these is scalar? The answer here is, remember, electric potential, which is known as voltage, is a scalar quantity. Kinetic energy is a scalar quantity. Just take like we all know that energy is a scalar quantity, okay? Yes. So what is not a scalar quantity here? Torque is not a scalar quantity, it's a vector quantity. Momentum is a vector quantity. So the right answer here is what? Is I and IV, which is what? Which is D. Okay, so please take note, okay? They will surely ask you a question like this. Which was also okay, which is a vector, which is not a vector. Take note that quantities like force, momentum, moment, like there are very many. Those quantities are what? Those quantities are vectors, okay? While quantities like mass, length, time, energy, power, like there are all many, okay? So please take note of all those type of. Just go and learn them, okay? It's very, very important. Okay, so this answer here is what? D. Now this other question they said. Okay, this other question 2, okay, I didn't write the full question. Now this time, they just gave us the diagram and they asked us to look for what? The resultant, okay? So this question is coming out from vector, right? Yes. Now this type of vector, if you look at the question, this is the diagram, right? Yes. If you look at I'm coming. Now if you look at these two vectors, this vector 6, this vector 8. If you look at these two vectors, they are perpendicular to each other, right? Yes, this is perpendicular for you, right? Yes, so therefore this type of vectors, these are perpendicular vectors, right? And they're asking us to look for what? They're asking us to look for what? The resultant, right? Yes, how are you going to do this? To solve questions under perpendicular vector is very easy. We will use what? Pythagoras theorem, right? Yes, Pythagoras theorem is what? A square equals to B square plus C square, right? Yes. So we can replace this letter with what? we can do it like this. Since we're looking for resultant using Pythagoras theorem, it says something as what? Arrow square equals to a square plus b square, right? Yes. So our a will be what? Our this will be a, this will what? This will be b, right? Yes. So let's continue. A is what? A is what? A is 6, right? Yes, a is 6, then the square. B is what? B is 8, right? Then the square, right? So we're looking at what? Arrow, right? So the square of 6 is 36, the square of 8 is 64, right? So if you add them to give us what? To give us 100, right? So arrow square is equals to 100. What are we looking for? We're looking for arrow. So we take the square root of both sides. This square will cancel this square root. So what is the square root of 100? Square root of 100 is 10. So the answer here is what? Is 10, which is D. Now let's move to the next question, which is more complicated. And this is what most students usually find difficult to solve. Okay, now this question, if you look at it, this question is what is from here, is from resolution of vectors. Okay, they said the figure above shows 4 forces: 3 newton, 10 newton, 3 root 3 newton, and 6 newton acting on a particle. The resultant of the 4 forces is, so that's something for the results, for the resultant of coming, okay, of this 4 forces. How are we going to do this type of question? Now let me show you guys easy way to solve questions from resolution of vectors. Let me show you guys easy way. Now you guys need to have knowledge of the four and these 4 quadrants, right? Four cardinal point, right? Yeah, we all know that this place is what the positive axis, this is what the negative axis, right? Yeah, so please take note of this, very, very important. Okay, this side is known as what the positive x-axis, right side is known as what the negative x-axis, right? Yes. Now the positive x-axis can also be known as what? It's also known as east. Okay, so this side is known as east. Then what about up? The positive axis is also known as what? It's just known as what? North. Okay, north is upward, while the negative x-axis is also known as what? West. Then the negative y-axis is also known as what? South. Okay, yes. Now there are some important things I'll be telling you guys here. Okay, so take note that the east, this positive west, right? Positive x-axis or east, the angle here is usually 0 degree, usually 0 degree or 360 degree. Okay, so please take note of all this because we use them. Then for north, the angle in north is what? Is usually what? Usually 90 degree. Okay, very important. Then for west, the angle in west is what? Usually what? 180 degree. Then for south, the angle in south is what? 270 degree. Right? Yes. Now I want to tell you guys something. This is very important. Okay. Now when forming an angle, and let's say for example, I want to form an angle now. Let's say okay. Let's say when forming an angle, let's say this is a particular vector inclined at an angle. When forming an angle, we make reference to the positive x-axis. Okay, we form angle with respect or we reference towards the positive x-axis. Okay, so this is the positive x-axis, right? If we want to form an angle, we form angle from the positive x-axis. So now to form angle here, I will draw the angle from here. From what? From the positive x-axis, right? Yes, then I'll put the angle I want to put here, right? Yes, now let's go back to this place. Now, when forming an angle, we always make reference, we usually start from the positive x-axis, right? Yes, so if I want to form an angle now, so let's say that if here is 90, then there is 0 or 360. So let's say that from here to here, because we make reference to what? We make reference to the positive x-axis. So let's say that if I want to draw the angle from here to here will be what? So it's from the positive x-axis, right? So let's say that from here to here is what? Is 90, right? Yeah, so the angle here is what is from here to here is what? Is 90, right? Now before I continue, we all know that in mass, when two lines are perpendicular to each other, the angle between them is what? Is only 90 degree, right? Yeah, so when two lines are perpendicular to each other, the angle between them is what? 90 degree. Now if you look at these 4 cardinal points, you find that the four lines, they are perpendicular to each other. Look at it. Look at this place, these guys, they are perpendicular. If you look at this place, these guys are perpendicular. If you look at this place, these guys are perpendicular. If you look at this place, these guys, they are what? Perpendicular, right? Yes. So let's tell you that the angle here is 190, the angle here is 90, the angle here is 90, the angle here is 190, right? Yes, but don't get yourself confused. Now, when you want to form an angle, I told you guys that we make reference to what? The positive s, right? So if you draw from positive s to this place, the angle is what? The angle is 90, right? Yes. 90, right? Yes. Now, if we draw from positive x-axis towards to the negative x-axis, what will be the angle? The angle will be what? Will be 180, right? How? 90 plus 90 will give us 180. So that is very important, okay? So now let's continue. If we draw from positive x-axis, now remember, it's from positive x-axis. Draw from positive x-axis to the negative y-axis. What will be the angle? The angle will be what? The angle will be 270 because where 90 plus 90 plus 90 will give us 270. Now, if we draw from positive, if we make an angle from positive x-axis to the positive x-axis, something like this, the angle will be what? The angle here will be what? Will be 360 degree or what? Zero. Okay, will be 360 degree. How? Because 90 plus 90 plus 90 plus 90 will give us what? Give us 360 degree, right? Yeah. So please take note of all this. So in summary, because I want to show you guys easy way to solve questions from representation of vectors. Okay. So in summary to what we have been doing since, yeah. So in summary to everything, yeah. So let me tell you that okay, this side this is the east or positive x-axis, right? So the angle here is 0 degree or what 360 degree, right? Then the positive y-axis or the north, right, is what the angle is 90 degree, right? Yes. Then the negative x-axis, the angle is what is 180 degree, right? Then the negative y-axis or south, the angle is what 270 degree, right? Yes. Now have this in the back of your mind. And I also have this that from here to here, oh boy, is 90. Then from here to here is what is 180, right? Yes. So start from 191, 92, 93, 94, 95, 96, 97, to 180, right? Then angle from here to here will be what? Now, to be what? To be from that is from here, right? That from here to here will be what? Will be 270, right? Yeah. So that is tell you that if here is 180, that means that we add under 90 to it, making it 270, right? So that means that the angle start from what? 181, 182, 180, 184, 185, 186, 187, it gets to what? 270, right? Then from here to here to what? Here is what? Is 360 degree, right? So that is if we start from here. Since here is 270 degrees, so that is tell you that the next one will be 271, 272, 273 till it gets to what? 360, right? Yes. So now, let's take note of all these things. Now, let's solve the question. Now, it's very, very easy. I'm not going to waste your time. Okay, so they said, they gave us four forces, right? Yeah, okay. They said, okay, the resultant of the four forces is, it's very easy. How to solve the trick I want to tell you is the direction of two parts. This will be for the y-axis, this will be for what? The x-axis, right? So it's very easy, okay? Now, another time I'm telling you guys that the y-axis we use what we usually use sine, the x-axis we usually use what? Cos. Simple. Now let's start now. What is the very first force here? Very first force, because we usually start from this place. What is the very first force here? The very first force is 3, right? 3. Then since we are under we're dealing with y-axis to what? To be sine, right? To be sine. So sine 3 sine. Now, what is the angle of 3? This 3 Newton. Now what is the angle? 3 is usually what? 3 is at where? The force 3 Newton is at where? Is at the positive x-axis or east. Remember, I told you guys, positive x-axis or east. The angle there is what? Is 0 degree or what? 360 degree, right? So to now it will be something like this. 3 sine 360 degree. Okay, I can still use 0. Okay, so I can use, remember, east, this trinity is at what? Is at the east. Okay, it's at the east. So east is 0 or 360 degrees. So we can use 0, we can use 360 degree. Okay, then we'll go to this place. We will do the same thing. To be what? 3, then this sign will not turn to cos 0 degree. Then we'll do plus. We continue. The next force is what? Is 10. And 10 is inclined at what angle? 30 degree. So the what? We do something like 10 sine what? 30 degree. Go to this place, do plus 10 cos what? 30 degrees. Very simple. Then go to the next place, plus again. This one, 3 root 3, right? 3 root 3 sine. Now this 3 root 3 is at where? 3 root 3 is facing up. Remember, this is north, right? Or positive y-axis. Remember, so you guys, north is what? North is what? The angle of north is what? 90 degree. Now look at it. This 3 root 3, is it inclined at any angle? No. This 3 root 3 is at the north. Right? Remember, north is what? North is 90 degree. So I'll put what? 90 degree. Then on this side, I'll not the same thing. I'll do plus 3 root 3 cos. It might be cos, then 90 degree. Then the last part, go to this place. I'll do like this 6. Then sine, then go to this place 6 cos. Now which angle am I going to use? Am I going to use 60 here? No, the reason I'm not going to use 60 is because normally according to the four cardinal points, we all know that from here to here is what? From here to here is 90. Then from this place to this place is what? Is 270. Therefore, we can never have 60 here. I don't even understand. We can never have 60 here. I don't even get. Okay, but though this angle is very correct. Yes, it's very correct. That is if you specify it further. Okay. Now, but for the method I'm showing you guys, you look at it. That's from here to here is 90. So that's tell you that 60 is really lies inside this place, right? Yes. Before we get to 90, we need to get to 60 first, right? Yes. So if from here to here is 90, then from this place to here is 270. So let's say that 60 usually lies inside here, right? Yes. So now what is the actual angle here? Look, if you look at, let me draw it to you. Now what is the actual angle here? I'm coming. Okay, so this is how it is, right? So it is 6 Newton, then the angle here is 60. Okay, that's this place. Now, if you look at this place generally, now the 60 is usually inside here, right? Usually inside here, right? Yes. Now, what is this? Is not the actual angle here. But though this thing is correct too, but this is not the actual angle here. Now, what will be the actual angle here? Remember, if here is remember, I told you guys that negative SR is 180, right? Yes. So if here is 180, here can never be 60. I understand. So if here is 180, then the angle from this place, from this negative x-axis to this place, will be what? We just add 60 to 180. 60 to 180 will be what? Will be what? 240, right? Yeah, 60 to 180 will be what? 240. So therefore, the angle here is what? Is actually what? 240 degree, right? Yes, it's 240. Okay. Yes, it's 240. So let's continue. So it might be what? So the angle here is what? Is actually what? 240. Okay. So sine 240 here will be what? Cos 240. So if we do everything, let's do everything. Okay. So let's do everything. Let's just use your calculator straight. 3 sine 0, then close bracket plus 10 sine 30, close bracket, then plus 3 root 3, then sine what? Sine 90. Then plus what? 6 sine 240. Okay, so our y will be what? Our y will be 5. Okay, y will be equals to what? Everything will be what? Will be 5. Then when we bar heads, if we do everything, what will be our answer? So if we do everything, here will be what? 3 cos 0 plus 10 cos 30, then plus 3 root 3 cos 90, then plus 6 cos 240. So if we do everything here, we get 8.66. So our x is equal to what? 8.66. So what I'm going to do next is very easy. We are looking for a result, right? Using that Pythagoras theory, r square equals to a square plus b square. Since we are dealing with y, r square because what? Y square plus what? S square, right? Yes. So r square because what? Y is what? 5, right? Then the square. S is what? 8.66. Then the square. So if we do everything, the square of 5 is 25, right? Then plus the square of 8.66. So the square is what? Is 74. Approximately 75, right? Yes. So 25 plus 75 will give us what? 25 plus 75 will give us 100, right? Yes. So we're looking for arrow. So take the square root of both sides. So this square will cancel this square root. Then the square root of 100 is what? Is 10. So the answer here is what? The answer here is B, which is 10. So as you saw, our answer is what? Our answer is 10 Newton, right? It's 10. So B. Now let me show you guys other method to solve this type of question, okay? Especially at this part, okay? Now, if you look at this part very well, remember, let me just, I've told you guys that the actual angle here is 240 degrees, right? Yes. Now let me show you guys on that way. Now when it gets to somewhere like this, if you draw the angle, let's do it. Okay, this is the x-axis then. Alright, so this is 6 Newton, then this is the angle 60, right? Yes. Now remember, this is positive y-axis, this is positive x-axis, this is negative y, this is negative x, right? Yes. Now look at the angle very well. 60 degrees, right? This angle, where does it lie? It lies between negative x and negative y, right? Remember, where this is y, this is x, right? Yes. So if we don't want to convert these, if we don't want to use 240, we can use 60, right? So we can use 60, but we can use 60 degree, right? Yes, but we need to change this plus, we don't need to minus, because why this 60 is at where the word negative is a line between negative y and negative s. So what to be the y will be what? The y will be negative, right? Now what about for s? Remember, it's a line between negative s and negative y. So I'll put 60, I'll still put negative, right? Yes, let's just see it. So if we still do it like this, we get our right answer. You add that at the minus, add that at the minus, you get your answer. Okay. Yes. Now what if the angle, let's say what if the angle was is in somewhere like this, somewhere here, for example, let's say 40, and normally we all know that here can never be 40 degree, because why? Because from here to here is 90, so from here to here is 90, therefore here can never be 40 degree, right? Yes. So if we have something like this, if you look at it, this angle is between what? Positive, negative s, negative y, positive s. Now if you have something like this, if you don't have to add up all the angle to get the actual angle, you can still use this. But if you use this, if you use the angle, here will be what? And the positive, the y will be negative, because why? Because why? The angle is between the positive, negative y and what? Positive s. So the y will be negative. Y here will be what? Plus, because why? The angle is what? Between the negative y and what? Positive s. I don't even understand. Okay. So, but in this question, the angle here is what? Is 60 degree, right? Remember, we can use it. We can, yeah, I told you guys that you can still use it, or we can just add it if we add it to 40 degree. But if you want to just use it, then we are going to what? We are going to use, we turn this one to negative, minus, because where? Because the angle is between negative y and negative s. That is so that is that if we resolute it to the plus negative, because that is that we can resolute it to what? Negative y and negative s. So use minus, then we'll still use one minus in the s side, right? So if we do it, let's just do it, you see that we have our answer, we have the same answer. Okay, so that is just it. So let's do 3 sine 0, then plus 10 sine 30 degree, then plus 3 root 3, then sine 90, then minus 6 sine 60. So our answer here is 5, right? Y is 5. And remember, previously we got y as 5, right? Yes. So if we should do it out to conserve time, if we should do x, we have s equals to 8.66. Right? If we do everything, our arrow will be 10. So that is just it. Okay. Yes. Now there's something I'm going to tell you guys. Now remember that Jamb does not allow calculator, right? Yes. Now how are you going to do all this type of thing when you don't when you don't allow calculator? It's very easy. Okay, let me just tell you guys, for those that don't know, because Jamb in the calculator, that is in the computer, in the calculator there's really no sign, there's really no angle. I don't even understand. So how are you going to solve questions like this if they don't put angle in the calculator? So how are you going to do it? It's very easy. Okay, so you just need to know it. I don't even understand. Okay, so just take note that sine 30 is what? It's very important. Sine 30 is 0.5. Just know them. Sine 60 is what? Is 0.866. Okay, yeah, it's very important. Then it's not, if for cos it's now opposite. Cos 30 will be what? Will be 0.866. Then cos 60 will be what? Will be what? Will be 0.5. I don't even understand. So that is just it. Okay, cos 60 is 0.5, cos 30 is 0, is that is opposite to what? Opposite to sine. Now apart from that, just take note that both sine 45 is what? Is 0.7071. Cos 45 is still same as well, it's still 0.7071. So this, please take note of all this, because we're in in the exam, there's really no calculator. I mean, in the calculator though, but the calculator does not have angle. Okay, yes, then still take note that sine 0 is what? Take note that sine 0 is 0. Okay, then cos 0 will be what? Cos 0 will be 1, if I'm not mistaken. Okay, yes, sine 0 is 0, then cos 0 will be what? Cos 0 will be 1. Then another thing to take note of is that sine 90 is 1, then cos 90 will be what? Will be 0. Okay, so that is very, let me check it. So it's very important. Okay, sin cos 90 will be what? 0. So please take note of all this. Okay, yes, because in the example we not like you cannot usually the calculator does not have angle. Then another thing is that usually still root 3. Also in the calculator there is no square root. So how are you going to solve when there is no square root? How are you going to do this? If let's say they give you question in how are you going to do square root? How are you going to do it? It's very easy. Just know that root 3, this is very important. Root 2 is 1.4142. Take note of this. Root 3 is what? 1.73. Okay, so if it's not like this, if you want to simplify this, 3 root 3 will still be the same thing as what? 3 times, what is root 3? Root 3 is what? 1.73. Then sin what? Then sin 90, sin 90 is what? Sin 90 is 1. So if you multiply everything, you get a value. So that is just it. Okay, so please take note of root 2, root 3. Root 2 is 1.4142. Then root 3 is what? 1.73. Okay, yeah, so that is very, very important. So let's move to the next aspect. Okay, so that is that they will ask you questions that you expect questions from. Yeah, let's say which of these is scalar, which of this is a vector. Then calculation question like resolution of vector, then perpendicular vectors, and so on. Okay, yes. So now let's move to the next aspect, which is motion. Under this, we'll do questions on linear motion, projectile motion, circular motion, momentum as well. Okay, so let's move to the next aspect. All right, so let's continue with the next aspect. Okay, so we are in the next part of physics, which is motion. Okay, so these are places you usually expect questions from. Okay, now before I continue, if you want me to do the same thing for chemistry and biology, you can comment it below. Okay, now apart from that, also to be notified whenever I do that, just make sure that you subscribe to the channel. Okay, so which is very important, so that you guys can get updated. Okay, yes. So if you want me to do the same thing for chemistry and biology, you can comment it, okay, in the comment section. Okay, which is very, very important. And don't forget to subscribe so that you can get updated whenever I do so. Now this next aspect of question is from motion. Okay, now let's start this very first part. They said, remember under motion, you have linear motion, you have circular motion, we have momentum and force, we have simple harmonic motion, we also have projectile motion. So motion, this part usually covers a lot. Okay, so we are covering a lot of topic under this part. Okay, so now they say a train. Before I continue, I think yes, let me start with this first part. Okay, so to conserve space for this side. And then which of the following graph represents motion with uniform velocity? Now if you look at the four graph here, this four graph, look at it. This velocity over time, velocity over time, velocity over time, velocity over time. So this will tell you that this graph is what is a velocity time graph, right? Yes. So now I want to tell you guys something. Okay, so in a velocity time graph, let me see if I can. Okay, let me just tell you guys the answer. The answer here is said, which of the following graph represent motion with uniform velocity? A motion in uniform velocity is a type of motion with constant velocity. Okay, so the answer here is what? The answer here is D. Okay, yeah. So this type of motion, this graph represents motion with what? With a constant velocity or what? A uniform velocity. Now let me break it down further. Let me explain. So okay, now this question is from velocity time graph, right? Yes, that is a graph of velocity over what? Graph over time, right? Yes. Now in a velocity time graph, when you see ascending line like this coming from this origin, this line represents what? This line represents acceleration, or we can say accelerating, right? Let's just call it acceleration. Okay. Yes. Then when you see a straight line like this, yeah, this line does not show that the body is accelerating. It shows that the body is moving with a constant velocity. So that is why option D is correct, because in option D we have something like this, right? We have something like this, right? So this line is this one here. So this one represents what? Represents a uniform velocity. While this one represents acceleration, this one represents uniform velocity or constant velocity. Now when the line is a descending line like this, when line is a descending line, it means what? is what is deceleration, okay, deceleration, or you can say negative acceleration or retardation, right? Remember, deceleration is also called retardation. Okay, so let's tell you that graph like this. So let's tell you that this graph here is what represent this graph here represent acceleration. This graph here like this represents what represent deceleration. Then this graph here like this represents this one here represents what represent uniform velocity or uniform, yeah, uniform velocity or constant velocity. So this is very important, so take note of this. Okay, very important. Now let's move to the next question. Let's do question one first. Okay, this is very important. Now, in question one, they said, now this remember under linear motion there are three equations of linear motion, right? V is equals to u plus at, s equals to ut plus half at square. Then v square is equals to u square plus 2as. So make sure you know this formula, because definitely they will usually ask question from linear motion, right? Yes, they will definitely ask you question. They will ask question from velocity angular. They ask from linear motion is very important. Now look at these are three formulas and these are three equations of linear motion, right? Yes, we all know that this one is the final velocity, right? Final velocity. This one is the initial velocity, right? This one is acceleration. This one is time. While this one is what distance or displacement, right? Yes. So v is what? V is final velocity. U is what? Initial velocity. A is acceleration. T is what? Time. S is what? Distance, or we can say displacement. Distance or what? Displacement, right? Yes. So these are the three equations of linear motion, right? Yes. Now it's very easy. So depending on the type of question they give us, yeah, so it depends on the type of question they give us. So that is it depends on the question. So so the type of question determines the type of formula we are going to use. So look at this one. They say a train has an initial velocity of 44. So u is what? U is what? 44. Remember, I told you guys that u is what? Initial velocity. Then accelerate and okay, and an acceleration of minus 4 meter per second. So a is what? A is minus 4 meter per second, right? So the acceleration is on minus 4. Then its velocity after 10 seconds is, so time is what? Time is 10 seconds. Then we are looking, they say its velocity after 10 seconds. So we're looking for what? The final velocity. So let's look at it, but which of the formula we are going to use? We're going to use the very first formula, because the first formula has final velocity, it has time, it has acceleration, it has what? Initial velocity. So that just is, so we're looking for v. So v is equals to u plus what? 80. So we're looking for v, right? U is what? 44. Then plus a is what? A is minus 4, right? Then times time is what? Time is 10. So minus 4 times 10 give us minus 40. Then 44, okay? So now plus times minus will give us what? Plus times minus will give us minus, right? Yeah, so 44 minus 4 will give, minus 44 minus 4 to give us 4. So the answer is what? 4 meter per second, which is B. Okay, yes. So these are you solve questions on the linear motion. Okay, let's do question. Next question. Okay, so this next question said a car moves with an initial velocity of 25. So u is what? 25. So just take note of this type of questions. And reaches a velocity of 45. So v is what? That is the final velocity is what? 45, right? Then they said in what? In 10 seconds. So time is what? 10. They said what is the acceleration? The same formula we used just now. We're looking for what? We're looking for A. So it depends on the type of question. Now in some particular question, they'll give you A, they'll give you U, V, they'll give you A. They'll say look for displacement or distance. Okay, now take note that this is very important. When a car starts, when an object starts from rest, then when an object comes to rest. Now when an object starts from rest, the initial velocity is what? 0. Then when an object comes to rest, the final velocity is what? 0. Okay, so please take note of this type of question, because most times they will not give you initial velocity, they'll give you indirectly. They'll say the car start from rest or the object start from rest. So let's say that u was 0, right? Yes. So now we're looking for this type of question, we're looking for acceleration. So we're using the first formula. So v is equals to what? U plus 80, right? So v is 45, u is what? U is 25. Then we're looking for a, right? Then t is what? 10. Right, so if this one cross the other side to be 45, it crossed to one minus, not to minus, right? So minus 25 is equals to 8 times 10 give us 10a, right? So 45 minus 25 is what? Is 20, right? Then equals to 10a. We're looking for a, we drop both side about 10, right? To make a stand alone. So 20 divided 10 is what? Is 2. So acceleration is what? 2, which is C. Okay, yes. Now let's move to the last question here, which is velocity time graph. Okay, yes. Now most students usually find it difficult to solve question coming out from velocity time graph. Okay, so I will show you guys easy way to solve this type of question. Okay, now before then, please and please, if you have not yet subscribed, please do so. Okay, so that you can get updated whenever I drop whenever I drop videos on chemistry, biology, as well as the other part of this physics revision, which is on wave and electricity. Okay, so now let's continue. Okay, I said this on that velocity diagram. So to solve it is to solve questions on that velocity diagram very easy. Okay, so it's to analyze the question. They said a car which starts from rest and is accelerated uniformly. Okay, so since the velocity time graph, we need to draw the graph. Okay, this velocity time graph, velocity over our time. The very first thing you need to do, draw the graph, right? Yes, so to be the graph is usually what velocity over our time, right? The next thing we are going to do is control. Let's continue. Now they say a car which starts from rest and is accelerated. Remember, start from rest. U is what? U is what? 0, right? Start from rest, okay? And is accelerated uniformly at a rate of 3 meter per second for 3 meter per second square for 5 seconds, right? Now this, look at this. They said accelerated uniformly at the rate of 3 meter per second square. So the acceleration is what? The acceleration is 3, right? Then for what? 5 seconds. So the very first time is what? Very first time is 5, right? Yes. Now we are going to fill it into all this place. Now if you look at this very well, this is a velocity time graph, right? Yes. Now remember, previously I told you guys that this line starts from what? Acceleration. This line starts from what? Constant velocity or constant motion or constant or uniform velocity, right? Why this line stands from what? Deceleration, right? When the object is coming to rest. Acceleration when the object starts from rest, right? It's accelerating the velocity. Yes. Then this one is constant. This one is what? Deceleration, right? Or retardation when the object is coming to rest. Okay. Yes. Now look at it. They say start from rest and accelerated. So to be something like this, right? Yes. Accelerated uniformly at the rate of what? At the rate of 3 meter per second square. So the acceleration is 3. They say for what? For 5 seconds, right? So generally the object accelerated for how many seconds? The time, remember, here will be everything under here will be for time. Everything here will be what? Will be for velocity, right? Yeah. So take note. The values here will be for velocity. The values here will be for what? Time, right? Look at it. They said accelerated uniformly at what? The rate of 3 meter per second square for 5 seconds. So it accelerated at what? At the time is what? 5 seconds, right? Now what about this? What about the velocity? Remember, here will be for velocity, right? Where will be for velocity, right? Now what is velocity? Is the velocity they give us velocity? The velocity, remember, u is 0, right? So forget about that one. So now that means here will be 0. So let's forget about that one. Now they give us the velocity here. No, that is V. They give us acceleration. So we need to convert this acceleration to what? To velocity. Using those our normal formula, V equals to U plus AT, right? Because why? Because what we usually stay here will be what? Usually velocity, not acceleration, right? So what are we going to do? U is what? 0. A is what? A is 3. T is 5, right? So 3 times 5 will give us 15. So velocity is 15. So that is saying that the car accelerated car accelerated uniformly at the rate of 3 meter per second for 5 seconds, right? 3 meter per second square for 5 seconds. So let's say that the car was moving the velocity of what? Of 15, right? The acceleration was 3. The velocity is 15, right? So converted this acceleration to what? The velocity which is 15, right? So let's say that the car moving the velocity of what? 15 meter per second for what? For what? For 5 seconds. And let's continue. It attains a velocity which is maintained for 1 minute. Now they're telling us that this velocity, which is 15, it was maintained. Now remember, I told you guys, this one is acceleration. This one is what? Constant velocity or constant or uniform velocity. Why this one is what? Deceleration. This one means when the body accelerates, which was this. Then look at it. This speed, with this velocity, which is 15, they told us that they said maintained. So let's say that the body was no longer accelerating, it maintained this speed. Look at it, maintain this 15. Right? It maintained it. Right? It maintained the velocity. Let me understand. They say maintain it for what? For 1 minute. Remember, this is 1 minute. Now we're dealing with seconds. So 1 minute stays same thing as well 60 seconds, right? 60 seconds make 1 minute, right? So 1 minute is as 60 seconds. So they're telling us that this speed was it maintain this velocity or speed for what? For how many for 1 minute. Right? 1 minute is same thing as well 60 seconds, right? 60 seconds, right? Let's go to here. You maintain this speed for what? For what? For how many seconds? You maintain the speed for what? 60 seconds, right? Yes. Now am I going to add 60 here? And am I going to yes, I'm going to definitely put 60. But is the value actually 60 here? No, because where 60 plus 5 will give us what? Will give us 65. So if the right value here will be what? Will be 65. We are adding. Remember, we are adding. Time is the scalar quantity, so we add. So this velocity was maintained for how many for 1 minute, which is what the 60 seconds, right? Remember, we're using seconds. So it was maintained for 60 seconds. So 60 plus 5 will give us 65. So the value here will be 65, right? Yes. Now let's continue. So remember, this one is constant velocity, right? You maintain this speed, this velocity for 60 seconds, right? And let's continue. The car is then brought to rest, comes to rest or brought to rest, anyone, after 3 seconds. Now remember, I told you guys that this one stands for what? Deceleration or what? When the object comes to rest, right? Yes. So I'll do something like this, right? Because it means deceleration, right? Or when the object comes to rest. Now the object decelerates or comes to rest at where? At after one, how many the time is what? After 3 seconds, right? So 3. Now am I going to actually have 3 here? No. Though it's 3, right? So 3 remember scalar is scalar quantity, so usually add scalar quantities together. So 3 plus 65 is what? Is 68. So everything will be what? Be 68. So we have successfully analyzed the velocity time graph to be something like this. We have analyzed it, right? Yes. Now let's go to the question. They said calculate the total distance covered. So how are we going to calculate the total distance covered? It's very easy to calculate total distance covered. To calculate total distance covered, the total distance covered usually equals to what? Usually equals to the area under the graph. Equals to the area under the graph. Area under the graph. Okay, area under the graph. This is a graph, right? So the area under the graph. Now let's continue. Now what is the area under the graph? Now I mean look at this. Look at this graph. Or if you look at this. This is made up of two different shapes. This is made up of triangles, right? It's made up of triangle. This is a triangle, this is a triangle. Then it's made up of what? A rectangle, right? Yes. So to get the total distance usually equals to the area of the shape inside the graph, the area under the graph. Okay, so to look for the total distance, we look for what? I mean, look, there are three shapes here, right? Three shapes, two triangle, one rectangle, right? So one triangle, one rectangle, another triangle. So to look at total distance is equals to what? Usually equals to, let me clean this part. So let me use this place. So the total distance usually equals to the total distance cover equals to what? The area of a triangle, right? Then plus, now the next thing is, the next shape is what? The rectangle. So plus area of what? A rectangle. Area of rectangle. Then plus, so the next shape is what? Is a triangle plus area of what? Of triangle, right? Yes. Now let's consider. Now what is the area of a triangle generally? What is it for? The area of a triangle is what? The area of a triangle is half base times height. Right? Wherever the area of a rectangle is length times breadth. Then plus, what is the area of a triangle? Half base times height, right? Now let's continue. Now half times the base. Now remember, this is a triangle generally. This is the apex, this is the base. So this part here is what? Is the base, right? Yeah, so this is the base of a triangle. The base of a triangle is what? The base of what is 5. Then times what about the height? Now this is the height, right? The height from here to here. The height is what? The height is 15. So 15. Then plus, now length times breadth. So this is length, right? This is length. This is length. This is length, right? This is length. This is length, right? Length. Why this one is side is what? Is breadth, right? Yes. So this side is length. This side is length. This side is breadth, right? So this length. This is length. Length is what? Is it 65 or 65 minus 5 is what? 60. So from here to here is what is actually 60 because 65 because 60 plus 65 will give because 60 plus 5 will give us 65. So the length from here to here is what is 60. So the length is what length is 60. Then times sorry about the breadth. This is the breadth. The breadth is what the breadth is what the breadth is 15. Okay, then plus now under half again, right? So under half. Then times the base. This is the base, right? The base of the triangle. So this is the base. Now from 68 minus 65 is 3. So from 65 to 68, how many what is the value there? It's 3, right? So 3 plus 65 gives us 3. So the base is what 3. Then times. Don't worry about the height. From here to here, this is the height of the triangle, right? So the height is what 15. So if you have done it like this, yes, so we just add everything, do everything. If we do everything, we get our what? We get our answer. So half times 5 is 2.5, right? It's 2.5 coming. So um so half times 5 is what is 2.5, right? Then 2.5 times 15, then plus 60 times 15, then plus half times 3 is 1.5. 1.5 times 15. So let's do it now with calculator. So we just do it, okay? So to be 2.5 times 15, then plus 60 times 15, then plus 1.5 times 15. So answer is 960. So the total distance covered in the less than graph was 960 meter. So the answer is what is D. So these are the solved questions. So they tell you to calculate for total distance covered. Just look for the areas of the shape under the inside the graph or under the graph. Okay, now let's move to the next aspect of questions.